Hi, everyone. I thought I'd go ahead and just record my notes with audio at the beginning and upload those to Canvas for you. So that way you have a chance to listen to what's going on as I write. And then during our Zoom meetings, you can actually ask me questions about the notes or the examples, or if you're having any questions off of the homework. I thought that might be a better way to use our time. So right now we are using our 8.2 notes. And in 8.2, let me go and grab my notes for you. In 8.2, we're still looking at solving a triangle. But this time, as we're solving the triangle, what we're going to notice is that we're not automatically given a right triangle. That's going to be a special case, and that's what 8.1 was telling us to do. So now what we're looking at is, if you look at our topic up here, it says not all triangles are right triangles. And in fact, those triangles that happen to be not right triangles are called oblique triangles. All that an oblique triangle actually means is that all of the angles must be acute, or two are acute with an obtuse. Remember, the word acute just means an angle that measures between 0 and 90, and the word obtuse refers to an angle that measures more than 90 but less than 180 degrees. There are actually 4 cases where we can actually solve these oblique triangles, and 2 of the cases actually can be solved by the law of sines. And so we'll take a look at those in section 8.2. The first thing is, what is the law of sines theorem? And it says for any triangle with sides A, B, and C, and opposite angles A, B, and C respectively, the theorem goes something like this. The sine of angle A is to A, its opposite side, as the sine of angle B is to B, its side, as sine of C, angle C, is to its opposite side, C. We also know in this for any triangle that the sum of the angles is always 180 degrees. Now, this theorem is just a shorthand way to write 3 different proportions. One of the proportions that you'll see here happens to be the sine of A is to A, as the sine of B is to B. So one of our ways to use the law of sines might be, if you're given information about 3 of the 4 unknowns, let's say you know about angle A and angle B, and you know something about side A, could we actually solve for side B? Well, sure. Another one of the proportions that we'd be able to actually solve would be, what if you know sine of A and you know side A? You might know angle C, but you're in search of now side C. So once again, there's another proportion that comes out of the law of sines. Finally, you can probably guess what the next one would be. The sine of angle B is to side B, as the sine of angle C is to its side C. So here are the 3 different proportions that actually come away from the law of sines for us. Now, as you and I start working on these triangles, and just the other, I guess it was yesterday, when we were looking at the triangle itself, we were making sure that everybody understood how to label their triangle. And for the right triangle, we always let angle C be the right angle. In an oblique triangle, you don't have a right angle, so it really doesn't matter where the angle C will be located. So here I've just put A, B, and C in a clockwise pattern for me. Remember, we said that across from angle A is going to be its side A, across from angle B is side B, and across from angle C, side C. So here are the 6 parts of the oblique triangle. And because of this, and you can look at the proportions that we just wrote out. Each one of the proportions has 4 unknowns. Basically, you and I always need to have 3 parts, 3 of those different unknowns. We need values for them from our picture, from our problem, and then we can always set it up to find the missing one. So one of the cases that we study here will be angle side angle. An angle side angle, if you remember back from geometry, let me draw you a picture of this. The word side is between the 2 words angle. So like, for example, this is an angle right here that we would know. Let's say that's angle A. Another angle along the way might be this one here. We could call that one B. And the side that we're given is the side that's right between those 2 angles. Well, the name of this side here happens to be lowercase c, because if you think about it, draw a line to the vertex that's opposite from that side, and sure enough, that would be angle C there. So this must be side C. So when you're talking about an angle side angle set up for the triangle, you're talking about a side that's between 2 angles given. Now, it didn't have to just be this version. Let me change colors here and show you. You could have also said, well, what if I'm given A is the angle I know, and let's say that I know angle C. Well, what's the side in between angle A and angle C? That would be right here, and that would have to be side B. So you've got 3 different versions that you can pull off if you need to. It just kind of depends upon either the situation from the problem, or if it's just generic, you can mark up your diagram. One of the other cases that we have here is what we call SAA. And you'll notice the way that the letters are placed in this, and also the way it's named. It's called the side angle angle. What that means is that if you approach the triangle, and let's go ahead and give it a name, A, B, and C, then if I tell you that I'm going to give you a side angle angle type triangle, then you and I would find a side to work with. Let's say I pick side B. Then the 2 angles that you would need would either have to be angle C and angle B, because you see how the side is not included. The first case, the first example was the ASA. That's when the side has to be between the 2 angles. Here, the side cannot be between the 2 angles. So one option was, if I'm given side B, then I need to have sides angle C and angle B. Let me change colors here again and show you that if I also went back and said, well, I want B to be the side that's given, then I could have also have had A, and then I would have had to have B. So again, you're kind of in control of this for the most part, depending upon the information that's given to you. So let me get rid of all of the markings that I just put up here on this side. And we can look at our next problem. This is actually an example of putting the law of sines together for us. And so remember, one of our cases is if the side is between 2 angles, or if the side is not between 2 angles, then that's what represents our case number 1 for us. For example, here it says solve the triangle. We've done this before in 8.1. In 8.1, we were given the fact that it was a right triangle, though. So we were automatically told one of the angles. Here in this case, nothing is said like that. It says solve the triangle. Well, angle A is 20, angle B is 80, and side A is 4. One of the best things for you to always do is to always draw what this picture is going to look like. Okay. And then once you draw it out and label your parts, then you'll know what type of triangle this actually is. So let me get a color here. And let's draw in a triangle then. Again, it doesn't have to be to scale. Okay. I noticed that both of these angles that are given are acute. And so I'm going to have a 20-degree angle, an 80-degree angle, so I could say maybe that's my 20-degree angle, and they told me to call that A. Up here, I could have like an 80-degree angle. They told me to call that angle B. And now they've also told me that that side A is known to be 4 units long. Well, that means that the side across from side A is across from angle A. This is where A is right here. Okay, we know it's worth 4. So the things that you and I have to go and find then according to this problem, we need to go and find angle C because we don't know how big that angle is. We do not know how large side B is, and we do not know how large side C is. So those 3 things that I've marked there in green, those are actually the things that we need to go and find now. Okay, let's go back and look at what the given was for the blacked markings here. You were given an angle A. Oops, just lost him. Angle A. You were also given angle B, and then you were given side A. Well, what this tells me then is this must be an side angle angle triangle scenario. Side angle angle. I was given one side with 2 angles that are on where the side is not between those 2 angles. So now in the law signs, remember we had kind of a triple proportion, if you want to call it that. We had the sign of A is to A, as the sign of B is to B, as the sign of C is to C. So now what I'll need to do then is decide what I want to do as far as information wise. Since they gave me angle A and angle B, it only makes sense that I would use this part of the proportion right here. The other reason I would probably do that is because angle A has been given to me. And so, or side A has been given to me rather. And so I know that I could set up a proportion that would say the sine of 20 degrees is to the value of 4, as the sine of 80 degrees is to side B, because that's one of my unknowns. I can cross multiply and solve for B this way. So if we cross multiply, we'd have B sine 20. That's equal to 4 times the sine of 80 degrees. Divide both sides by sine of 20 degrees. And now we can find out what the value of B is going to be. Now, most of our answers here are going to end up being decimal. So I'll run pretty much the same rule as I did in 8.1 when we're looking for lengths of sides. We'll go ahead and round to 2 decimal places. And when we're looking for angles, we'll go to 1 decimal place. So in this case right here, if you'll type into your calculator what this value would be, we're going to look for 4. Make sure you're in degrees. 4 sine of 80 degrees. And then we're going to divide that by the sine of 20 degrees. And we should get some value like 11.52. That's rounded. Okay, 11.52. So here's one of the unknowns that we were asked to find. There's the value for B. Now, let's go ahead and get in a habit of doing this so that you won't forget how to do it later on when it's absolutely necessary. The value of B has been rounded, and since it's been rounded, we need to put into our calculator the exact value. So at this point, what you can do is you can go to your calculator and you can hit the stow key, and it's one keystroke above the on-off key. So with this value up on your calculator, 11.51754097, it doesn't stop, it keeps on going. We're going to hit the store key, and you're going to see something that pops up like ANS with an arrow. Now it's your job to name the stored value. And so since mine happens to be for the letter B, I'm going to go to alpha. That's the green key on your calculator. And I'm going to look for the letter B. And the letter B happens to be on the apps keystroke. So I'm looking for alpha B. When I have that, it says the answer is going to go to B, hit enter, and now he's stored. So now the value in my calculator, big B, is the exact value of what 4 sine 80 degrees divided by sine 20 degrees is going to be. So that's one of the values we were looking for. Another one of the values we were looking for is angle C. And we actually are in pretty good luck here with angle C, because if you remember, there's 180 degrees in a triangle. So if we take 20 degrees, which is angle A, we add that to 80 degrees, and we add that to the mystery angle C, that total should be 180. So when we come in there, we can find out now that C must have been 100, whoops, how about 80 degrees if I can subtract? So this is 100. If you subtract 100 from both sides, you'll get 80 degrees. Well, weird enough, we just happen to have what they call an isosceles triangle, where two of the angles are identical. Then that means that two of the sides have to measure identically. And knowing this piece of information, it's not going to be too wow, surprise that you and I are about to get another 11.52 measurement for side C. Let me put in here what we found out. We found out that this is also 80 degrees. And so since angle B and angle C are both 80 degrees, I know that side B and side C will be the same also. So I already know what the answer to side C will be, but we can show how we would actually work it. The one thing that will not work here, you cannot use the Pythagorean theorem anymore. Pythagorean theorem is only for the right triangle. You cannot use SOHCAHTOA anymore because we don't have a right triangle. So you're at the mercy now of using the law of sines to get through the problem. So what we're trying to do here then, my only unknown left for me to actually calculate is the value of side C. So if I use side C then, I'm going to use the pair that I know from the problem. And I know that the sine, and I'm looking for the given. Sine of 20 was given to me, and we were given 4. I'm going to look for side C now, and so that means I'm going to have once again the sine of angle C, which happens to be 80 degrees. So you can see that the math is going to look identical. Basically, when I go and solve for C then, I would end up with something like 4 times the sine of 80 degrees. That'll be divided then by the sine of 20 degrees. And again, this will be 11.52. So here is my other value that I was looking for. And now I can say that the triangle has been solved.